everyone. I want to take some time now to go over nuclear chemistry with you, specifically looking at how to balance nuclear equations and work half-life problems. So previously in the semester we worked on chemical reactions, and the key thing with balancing chemical reactions is that we had to have the same number of atoms on the reactant side as we did on the product side. When we look at nuclear chemistry, we're only concerned with what's happening within the nucleus. But the concept of balancing is still the same. We have to have the same number of protons and neutrons at the beginning of our reaction as we do at the end of the reaction. So balancing nuclear equations or completing nuclear equations is really based off of what is happening in the nucleus with the different particles that can be released. Now you have a cheat sheet for atomic chemistry, and you are going to want to have this when you work on your Unit 6 assessment. Nuclear chemistry, not atomic chemistry, nuclear chemistry. The cheat sheet has the correct atomic notation as well as the different types of nuclear particles and the different examples of the types of decay that we can have, as well as a little bit of information about half-life. So to start, I want to work on the nuclear equation worksheet that was part of your Unit 16 Week 16 Day 1 assignments. So the first one of those, when you look, it says you have alpha decay. So that's alpha decay of berkelium 247. Okay, so we're going to have alpha decay of berkelium 247. Now, this 247 is our mass number, which is our number of protons plus our number of neutrons. Okay, so when we look at all of these different elements in these nuclear equations, you're going to need to have your periodic table handy as well, because you're going to need to get the atomic number. So when I look at my periodic table, the first thing I've got to do is get my symbol for berkelium. And I know berkelium is Bk, and it tells me that my mass number is 247. So that's going to go up here on the top to the left of my symbol. And then down below that, I need my number of protons, which is my atomic number, and I'll look and see that berkelium is element number 97. So this is the correct atomic notation that we're going to use. Okay, so this is what I'm starting with. It's going to decay. So that's going to be my arrow. I'm told that it's going to exhibit alpha decay. So what that means is it's going to emit an alpha particle. So I go to my cheat sheet and I see that an alpha particle is really the same thing as a helium nucleus. So I'm going to write my alpha particle here. Okay. But when it decays, when it emits this alpha particle, there's going to be something left. There's going to be another element left. So my job is to figure out what is that element, what's left. In order to do that, I'm going to look at my mass numbers, okay, on either side of my arrow, and I'm going to look at my atomic numbers on either side of my arrow. So I have 247 as my mass number to start with, and I've already put a 4 here. So in order to get my mass number for this missing element here, I have to subtract. So I'm going to say 247 minus 4, so that's going to give me 243. Okay, so 243 is going to be my mass number for the missing element. I also have to do that for my atomic number here. So I'm going to say 97 minus 2. So my atomic number over here, or my number of protons, has got to be 95. And then I have to go to my periodic table and figure out what is element 95. Well, that's americium. Okay. Now, how do I know that this is correct? Well, I'm going to check my math. So I'm going to look over here. I have 247. Again, remember, this is my number of protons plus my number of neutrons. So I'm going to add these over here. 243 plus 4 equals 247. That matches. Okay, that matches what I have. Then I'm going to say 2 plus 95 equals 97. That's my number of protons. And I see I've got 97 here. That matches the 97 here. So your goal is to have your mass number, which is represented by the A, your atomic number, or your number of protons, represented by Z. So this would be A, this would be Z. And they need to be equal on both sides of your arrow. Okay, so we need A to equal A and Z to equal Z on both sides. So let's look at another example. So the second one says I've got beta decay of cadmium 113. So the first thing I've got to do is figure out, well, what is cadmium? Well, cadmium I know is Cd, and I'm told my mass number is 113, so that's going to go over here in its proper spot. And then I've got to find cadmium on my periodic table, and I see that its atomic number is 48, so that's going to go here. I've got a beta decay, so I look at my cheat sheet and I see that a beta decay is really the equivalent of an electron, and then I've got to figure out my missing element. Okay, so I have 113 over here, 0 here, so my mass number is going to stay 113, because 113 minus 0 is equal to 113. Now when I look at my atomic number, I have 48 here and negative 1 here. So when I say 48 minus a negative 1, that actually becomes 48 plus 1, which gives me 49. Okay, so you've really got to pay attention to that, because you are subtracting 48 minus, but you're subtracting a negative 1. And when we subtract a negative number, it becomes positive. So my atomic number is going to be 49, and I go and look at my periodic table, and I see that that is indium. So this would be my equation. I'm going to check myself. Okay, I'm going to say 0 plus 113 is equal to 113. Negative 1 plus 49, or 49 minus 1, is equal to 48. So I see that my math is correct. Okay. So let me show you one more of these. I'm going to skip down to number 6. Nickel 60 undergoes gamma decay. Okay. Now if you look at your cheat sheet, you see that a gamma particle looks like this. Okay. It's really not a particle. I've got it there with the particles, but really gamma decay is just high energy radiation. Okay. So it's not an actual particle. So if we have just gamma decay, the nucleus that we start with, in this case nickel 60, is going to be the same one that we end up with. So when I write this out, I'm going to put my 60 here. I go to my periodic table. Nickel is atomic number 28. It undergoes gamma decay, so I'm going to put my gamma particle, and I'm still left with nickel 60. Okay, I didn't change the element because I didn't actually get rid of a particle. I'm going to say it's a gamma particle. I'm going to say it's gamma decay, but just know it doesn't actually have any protons or any neutrons. So what I start with is what I end up with. Okay. Now on your final, you're going to have some nuclear equations that you're going to have to complete, and they're going to look something like this. So here is an example of a nuclear reaction. We need to balance this or complete it, okay? I'm looking for this missing element in my blank. I've got an alpha particle here, so I'm going to subtract. Because I've got this over here, I've got 214 as my mass number over here. I subtract the 4 that's already here, okay? So 214 minus 4 gives me 210. So I know that in my missing element here, my mass number has to be 210. Okay. Then I'm going to do the same thing with my atomic number. 84 minus 2, that gives me 82. So my atomic number here, my number of protons, has to be 82. I go to the periodic table, I look for element 82, and I see that that is lead. So I plug that in just like that. Okay. Let's look at another example. So let's say I have this. All right. So in this example, I have beryllium-9 here, and I've got something that I'm going to do to it here to give me carbon-12 and a neutron. So what I'm going to do is I'm going to add up what's on this side. I'm going to say 12 plus 1 gives me 13 for my mass number. 6 plus 0 gives me 6 for my atomic number. Then I'm going to go over to my other side, and I know that I've got to have 13 for my mass number over here. I've already got 9, so I'm going to say 13 minus 9 gives me 4. So my mass number has to be 4. I'm going to do the same thing for my atomic number. 6 minus 4 gives me 2. And I recognize this as an alpha particle. So I fill in the rest of that there with my symbol for helium. So you're going to have 25 of these on your Unit 6 assessment. Okay. One other thing that you're going to have on your Unit 6 assessment involves what we refer to as a radioactive decay series. The goal of any radioactive element is to get to a stable element. So we start with uranium-238. We want to get to a stable element. Lead-206 is stable. And we're going to have basically a disintegration or a decay series that happens spontaneously as we go through a series of alpha decay and beta decay to reach that stable element. And so each time you're going to emit some particle. So we have an alpha decay and then into a beta, 2 beta decays, and then a series of alpha and then beta, 1 alpha, 2 beta, and then 1 alpha to reach this. So on your assessment, you're going to be looking at the decay series for neptunium. And I've told you the order that they go in. You're not going to have to know anything there. You're just going to have to know the order. And basically what you're going to do is fill in each equation as it happens. So as I look at this decay series, I see I have uranium-238 that alpha decays into thorium-234. So I'm going to write an equation showing that. That looks like this. So I have my starting element, I decay into an alpha particle, and then thorium-234. Okay. Then in my next step, so this would be step 1, in my next step, my ending element here, my ending nuclide here, is going to become my starting nuclide in number 2. And this time I'm going to emit a beta particle, which looks like this. And I'm going to end up with protactinium-234. Okay.